All right, guys. Gripping audience, gripping topic. Okay, my name is Stefan Piesche. I'm the CTO at Constant Contact. And I'm here to talk a little bit about how we at Constant Contact use data stacks specifically from a technology strategy perspective. So it's not, if you expect to see Cassandra source code, this is the wrong session. So, just a quick word about who we are. Constant Contact is not that well known here on the West Coast. So we are a company that provides digital marketing services to about 500,000 small businesses. Everything from email marketing, social media, deals, event marketing, everything a small business needs to do promotions and market themselves. We have B2Cs, B2Bs, non-profits. So these are the small businesses you interact with on a daily basis. This is your local coffee shop, your print shop, maybe even your church, if you go to a church. So many small businesses you interact with on a daily basis. 70% of our customers are less than 10 employees, very, very, very small. And we engage these type of customers on a day-to-day basis about 10,000 times. So they call, we have free seminars all over the country, and we work a lot with them on teaching them how to be better marketers. Okay, on the engineering side, so we have about 200 software engineers, developers, and operations guys, manage about 2,500 servers and 2 data centers, about 2.5 petabyte of storage. Our technology stacks are Java and Ruby on Rails. And on the persistence side, we're using DB2, MySQL, and Cassandra, which is why we're all here today. And I'm going to talk to you a little bit about what we did specifically with the migration from DB2 to Cassandra. So I joined Constant Contact about 4 years ago, and specifically because Constant Contact wanted to grow from a single product, vertically grown company to a true multi-product company that has more customers, that acquires companies. So the goals for our SaaS company were to become a multi-product company. We wanted to go from one to many products, expand the organization, more development teams, and grow via mergers and acquisitions. And as you can imagine, that requires a little bit of a different technology approach than what you get when you start out. So when I joined Constant Contact, it was a business already for a decade with a fairly large install base, lots of customers, several million lines of code and various things. So at the end of the day, what we found when we got started on this journey was a single product, fairly monolithic architecture, right? And you probably all know what that means. Gigantic build, gigantic deployables, very database-centric, and a very narrow technology stack, really only using J2E, in a specific case, WebSphere and DB2. These were the 2 tools everything was written in. And as you can imagine, if you really want to go to a fast-growing company that builds out many, many products and scales to many more customers, you need to approach things a little differently. And the good news are, right, so monolithic architectures. So it's perfectly suited if you have a single product company that grows vertically, right? And it's very easy to understand for the development teams what's going on. It's one app, one request, one database, pretty straightforward to deal and to manage. And ultimately, it turned Constant Contact into the dominant player in email marketing. But we want to take things beyond that. Downsides are no horizontal scale, right? You have a single database. How do you scale this? And how do you do this without buying even more bigger database servers? So at that point in time, this was a Sun database server with 32 CPUs, 64 gigabytes of RAM, $1 million SAN attached to it, typical vertical scale. Velocity, right? Gigantic builds, gigantic code bases. Development velocity is fairly slow in that scenario. And the build times take forever, right? I mean, if you have one gigantic build, this is 1 million lines of code, it takes like 30 minutes for developers to do anything. So we decided we're going to change all of this and really across all tiers, from the application tiers, from technology stacks, and even down to the persistence tier. Many single points of failure, forgot that one, right? Something breaks within a monolithic architecture, even data architecture, everything goes down. So our technology strategy goals were then, we wanted to support multiple data centers. That leads a lot to the choices of the technologies we chose for this in Cassandra specifically. Horizontal scalability, right? Instead of buying from a 32 CPU database server to a 64 CPU database server, you wanted really to add servers and scale out instead of scaling out. Extensibility, if you want to go from one product to 2, 3, 4, 5, 6 products, your architecture has to be suited for that across all technology choices. Cost-effective and predictable, right? What does it take to roll out the next 100,000 customers? So today, we have over 500,000 customers, and we want to be sure what it will take to get to the 1 million customer mark. Improving development velocity. It's a big topic here, right? If you have one database, everybody steps on each other. And fault tolerance, and it goes back to if a single database, large scale, somebody writes a rogue query, everything goes down. So our technology strategy approach at multiple facets, and Cassandra is a big part of this, but let's talk about all the components. So service-oriented architecture, non-monolithic but distributed. Open source, so big strive from using vendor-related technology from the big ones, like in this specific case IBM, to go more and more open source. So interesting story here, right? When we got started with Cassandra, I was interviewed by some magazine about our choice, because we started very early with Cassandra with version 0.7. And they were asking us about why NoSQL and how we're planning to use it, and explained all of this. And I was misquoted in the article saying that I plan to replace all DB2 with Cassandra at Constant Contact. So you can imagine I got the call, frantic call from the IBM rep saying, I read you're going to replace all the DB2 with Cassandra. Oh my God, what are you doing? I said, don't worry. Cassandra is not a tool for all of it, so we're not going to replace all DB2 with Cassandra. The rest we'll replace with MySQL. And so an interesting journey really began for us, and going away from these very proprietary, high-cost solutions like the IBMs and the Oracles of the world. So DB2 replacement. We started out, okay, so MySQL, first choice, right? Integrate Ruby and Rails. Along the lines, we made an acquisition about 2.5 years ago of a company that had a CRM product, which was written in Ruby and Rails. Sharding. So the typical approach to scale data tiers specifically is to shard out the data, right? So instead of one database, you build 10 databases. We'll talk about that in a second. Continuous integration, continuous delivery of software. All technologies across all the tiers, including the data tier, have to support this, right? Schema tolerance, all of these type of things. Test-driven development and going from WebSphere to JBoss. So these were a little bit, so the cornerstones of the technology choices and the way we made decisions when we picked technologies. So we started out actually not looking at Cassandra and said, okay, we're just going to replace DB2 with MySQL. I'm going to shard this out. We're going to build many databases here. And the advantages are clear, right? It's a semi-predictable way to scale a data tier. But it's pretty difficult to introduce in a monolithic architecture. You can imagine that you have a bunch of code, a bunch of applications that thinks all data is in one place, right? Now if you say, okay, I'm going to have 10 databases now you're going to teach all those applications that data is no longer in one place. You're going to have to build abstraction layers and virtual database connections to really be able to scale this out indefinitely. And it turned out this was actually the key deciding factor why we chose Cassandra, we chose not to use a traditional MySQL sharding architecture. It's hard to manage, right? So if you have 20, 30 database instances, imagine what operations has to do when the schema changes. And it's not always cost effective, right? Okay, Cassandra to the rescue. So this was a little bit over 2 years ago. Cassandra was on version 0.6 that we realized that the change to Sharded database is pretty much the easy part on the infrastructure side, but changing all the code would have resulted in about a 1-year project, right? We gotta keep our customers happy, we gotta keep building products at the same time. So it's one of many projects. And nobody was really thrilled to hear that I said, okay, it's about a 1-year project. Nobody believes that anyway, so if I say 1 year, everybody thinks it's 2. And so we started looking at alternatives. And specifically, when we looked at our large-scale uses of data, we realized a lot of them are actually not relational in nature. There are 2 major types of data we're dealing with here. The first one is content. So this is all the marketing content our customers produce. So we send out about 4 to 4.5 billion emails a month, and this is comes across about, I would say, probably 3 million marketing campaigns. So every month, our customers produce 3 million pieces of large content, which is composed of smaller pieces, right? A newsletter has images and text and links and all of these type of things. So there's hundreds of millions of pieces of content every month. But this is stuff that you don't go, okay, find me a newsletter where I use the word Bob, right? Those use cases don't exist. So it's very much a store and retrieve type of use case where we need to scale out at low latency across our content management system. I said, okay, so really, we really don't need a traditional RDBMS here. And the second one was tracking events. So when we send out our 4 billion plus emails a month, we keep track of everything that happens after that, right? It's not only emails, it's social engagements. So it's email sends, opens, clicks, Facebook posts, Twitter posts, Facebook likes, LinkedIn. We capture all of this information to capture what's going on in the marketplace of our customers. And again, it's really just an event, right? Bob liked this post. Stefan opened this email. And so not really relational needs here needed. Why did we pick Cassandra? So we looked at all of the vendors. So it was a little over 2 years ago, right? And if you remember what we talked about on our technology strategy side, high performance, right? We have, at any point in time, we have somewhere between 50 and 75,000 people working on our system. And that doesn't seem a lot, but this is people that actually create content, that look at reports, that mine data, that manage their contacts in the CRM system. So high performance and low latency is most certainly a requirement here. Transparent sharding, right? So as I said, Cassandra, to all the monolithic applications that we still had at that point in time, looks like one data store. Right? There is no need to break it apart artificially and teach the applications that data is in many places now. Horizontally scalable, of course. Fault tolerant, multi-data center support, and cost effective. So specifically multi-data center support is very important to us. We have now 2 data centers, one in Boston, one in Santa Clara, and we're going to open more. And if you look at the landscape of database technologies, you will find that multi-data center support is actually a non-trivial exercise. Right? At that point in time, 2 years ago, you walked over the NoSQL vendors. Many of them had single point of failures. Very few of them had robust multi-data center WAN replication features, right? And even if you look at MySQL, right, try to do multi-master replication across the country. If you guys use MySQL, you know it's not that easy at all, actually, right? And so Cassandra attracted us because it's, at that point in time, and even today, its multi-data center replication features are the most mature in the NoSQL market, period. And it works really, really well. And we'll talk a little bit about the cluster layout at the end of the presentation. And fault tolerant is a must for us, right? With that many customers. Now, if we make a mistake and something breaks, it's not like our customers lose a ton of money. Right, as small businesses, but we ruin the lives of 500,000 people on a day-to-day basis. And we really try to have 4 nines uptime at all points in time. and be available to our customers so they can run their business. All right. And so what we did is we replaced the DB2 database that hosted the content. This was our first project. You can imagine, so this was a DB2 database. The database server alone was like 200 grand. It was attached to SAN for $1 million in one data center. And we replaced it with a Cassandra cluster that cost us $250,000 that had 10 times the performance and supported 2 data centers. It was a huge win for us, right? So now, as part of this Cassandra move, we put ourselves in a position to really make technology choices based on what is the need, what's the perfect way to solve this problem, right? And this is where it goes way beyond, of course, data tier and Cassandra as an architecture. It goes really building an SOA, building abstraction layers so you can replace pieces as you move along. So we'll talk a little bit about that cluster in a minute. So data, right? What are we storing in those clusters today? So it's 1 billion pieces of content totally that we need to manage here. Our customers stay with us for 4 years, right? So you do 500,000 times 10 million times 40 months or 48 months, you come to like 1 billion pieces of content that you need to manage and move around, and that you can't just back up, right? You want real-time access to that. I want to see the newsletter I wrote last year on Valentine's Day. I want to reuse that. 100 billion events tracked. So these are all the opens, clicks, Facebook likes, Twitter posts that the end consumers of our customers really produce, that we track, measure, and ultimately report on. And then as part of this, we derive analytics for them, and the total number of records we'll look at, that is, most of it is stored in Cassandra, is about between 100 and 150 billion records we derive analytics from. So we're not Netflix, okay, we're not eBay, but we still have a lot of data that we need to look at on behalf of our customers.
This number is for 1 day or 1 year?
Sorry?
What is the time frame for this number?
There's a total volume, right? So that's pretty much what we're looking at. This is for our current customer base, right, of 500,000 customers, a little bit more. And what that boils down to on the content side, it is a 17-node cluster with 36 terabyte usable for content, another 17-node cluster with the same capacity for those events, which will expand to 200 nodes over time. Right, so those 100 billion events actually don't fit into those 36 nodes. So that cluster will grow to first to double the size and then about triple the size over the next 2 to 3 years. And then there's a fairly small cluster with higher density. We replicate those tracking events too. We're using actually Cassandra, we're using DSC, and we're using Hadoop Analytics on top of that. And that cluster will about triple over the next 2 years. So what this looks like today is that cluster is, really spans those 2 data centers, right? So it's 36 nodes in Boston and 36 nodes in Santa Clara, triple replication each. So each data element exists 6 times, actually, right? And so this will get a lot of the performance and fault tolerance from. The downside is now, of course, if you add another 3rd or 4th data centers, that will then grow each of the existing 9 or 12 times if you stick with triple replication. And the event tracking cluster is pretty much the same thing. And then what we did is we ultimately inserted those 24 analytics nodes specifically in this event tracking cluster that Hadoop runs on. And the primary driver here is sorry about that. Okay. The primary driver for doing the, I'm sorry. I gotta go back one more. There we go. The primary driver for using Cassandra for analytics here is actually not having to move the data. So those tracking events, that's like 100 billion events, they come in at a rate of like 10,000 a second, right? And when we talk to big data vendors in the Hadoop space, the MCs, the IBMs, down to the startup cloud providers and say, how do you move that data out of Cassandra into a Hadoop cluster? I got a lot of silence. And so what we decided then is, okay, I guess then we'll just leave it in Cassandra and use DSC's Hadoop functionality to analyze the data, which now means that we have to move all the other data we want to analyze that is in RDBMS in there as well, but I'd say a small price to pay. And actually it works pretty well. So we're probably one of the first adopters of Hadoop on DSC, working with data stacks here, and with pretty good success so far. So the results really are of our Cassandra strategy is reduced cost of the data tier infrastructure by 80%, substantial, right? And this is just the infrastructure. I'm not even talking DB2 licensing and maintenance costs. Higher fault tolerance. We had no outages yet, at least no major ones. As always, are like little glitches here and there you have to deal with. We had 5 to 10 times the performance, right? We were stunned to see, probably if you guys use Cassandra, look at operational metrics, you see all of a sudden response times in the sub-millisecond range. You look at like the 300 microsecond response time for data retrieval, so that can't possibly be right, but it is. And it enables us to be able to use cases we really couldn't do before, right? So those 100 billion tracking events I was talking about, we're actually only now able to do because of Cassandra, because before that, on using traditional DB2 or even MySQL, it would be impossible to scale, right? The number of MySQL instances we would need to store 100 billion records at about 120 terabytes of data across the data centers is just way too hard. So the learnings are, living on the edge can pay off. We started very early with Cassandra. Start very small. Fortune favors the bold, but the prepared. So when we pick strategies like this and open source technologies like this, we really pick vendors like data stacks that help us figure these things out, right? So we don't go on these things blindly. We do a lot of prototyping. And from a migration process perspective, we stand up the new system parallel to DB2, the Cassandra system, do dual reads and dual writes on both systems and compare the results and make sure, okay, that's what the old system does, and eventually I can turn the old system off. What we actually found is differences in the result sets, and it turned out to be bugs in the existing system. So this is a little bit of a story of how we went about choosing Cassandra and what our results were. Questions? Carefully. So Cassandra, of course, is much more fault tolerant, much more schema tolerant, right? And we use the normal Cassandra tools to change the key spaces.
But suppose there's a problem on the back end. How do you prevent it?
You don't, right? And actually, so we have been doing this at constant contact, even on the relational side, always that all changes we made are always, on the data tier, are always backwards compatible. Right. And there's, of course, a lot of testing that goes ahead. We have a staging cluster. We test all of those changes beforehand.
What's your backup strategy?
How do you back up and where do you store your backups?
Yeah, so we do, right? And it was a little hard to understand first, right? So the first conversations were with our IT team. Well, we want to back up your Cassandra cluster. And we say, but why? I have every data element 6 times. How often do you need it? Right? But the reason really is that it's human error, right? So let's say somebody makes a mistake and changes the key spaces, drops some data, and then what? Right? So we use a normal Unix tools just to back up the file system only at the end of the day.
I wanted to ask what businesses are you adding? I didn't really understand. You said you're adding businesses horizontally, and then as you add businesses, you're scaling, but how did you actually affect that horizontal scaling as you add new businesses?
Yeah, so during this Cassandra migration project, our customer base grew from 250,000 to 500,000 small businesses. And all of these businesses create content, send email.
Scaling was just the quantity of customers.
Absolutely. It's a
So
quantity of,
same application, same scheme.
well, and it's more applications too. So when we started, we had 2 applications, now we have 6, right? We had 3 development teams, we have 13 now. So the entire organization grew. More products, more customers, more data.
So what did you typically do to scale that? Did it involve schema changes? New key spaces, new column families?
It's adding more nodes so far.
I have a follow-up on the same regarding the backup. So with 6, a replication factor of 6,
Yes.
that's a large amount of storage you need for backup. So are you deduping it in somehow that you are backing up only 1 copy?
We're only backing up 1 copy. We're not backing up all 6. Right. And in theory, it could in theory be, of course, with eventual consistency that you're missing 1, but it never really happens. So one more question, I think we're out of time. Okay, sorry. Thanks, guys.